To start programming, we have to understand what we are trying to achieve. Programming, simply put, is the art of telling the computer what we want to do, what needs to be calculated, what needs to be, let's say, presented on the screen, what colors are we using for our presentations, and so on. These can be all programmed with instructions to the computer. Now, all these complicated stuff need to be carefully designed in order for the computer to do what we really want. Now, how does the computer deal with our programs? Programs are written in high-level languages like Python. Python compiler will take our code and translate the code into something that the computer understands. Now, in some cases, we call the compiler interpreter. This is the case with Python. But in general, the role of a compiler or an interpreter is to translate code. How do we start writing programs? We can start by downloading a good IDE. IDE is an integrated development environment. If we navigate to python.org, we can go and download one of those. Now, in this case, this gives me the option to download for Mac OS, which is my platform. If you are using Windows, you can download the Windows version. This is one. Some people write code in Visual Studio Code. This is a more sophisticated IDE, but more complicated to deal with. If you really don't have any background on writing programs, maybe we should start with IDE that comes with Python. Some people write code in Jupyter. Jupyter is a notebook-style programming where you write several commands and then you can reload those commands. This is more used with data analysis, data science, and so on. Some people write code for back-end development. This is where we can write web applications. For example, we can use Django for that. Now let's switch back to python.org and let's say we downloaded the IDE and installed it on our platform. This should be a very straightforward process. If we launch the IDE, which is called idle, we can see this screen. This is what we call the Python shell. We could write Python programs here, which are simpler, let's say one-line commands. If we want to test something or do some quick calculations, we can use this view. If we want to write more complicated stuff, it's better that we open a new file and write down our instructions in that file, save it, and then ask the computer to run it. Here, we can simply write code in Python, click enter, and then just run it by the computer. If we want to start with the absolute basics, we can start with Python expressions. Expression is a line of code that produces a value. So wherever we use expressions, we can expect the computer to produce values for us. Values could be of different types and different categories. We'll get into that. So an expression is something like this. This is a simple expression, 2 plus 3. We could do a multiplication. We could do a division. These are simple arithmetic. We could do subtraction. These are all famous operations that we can do with Python. Division that is of type integer. What does that mean? The result is always an integer number, not a real number. In case of the true division, this is the result, which always be a real number. So let's say that we want to divide something that is not divisible by 2. This is the result that we get. If we go with double forward slash, we can get the integer part. What else do we have? We can also get the remainder of dividing 5 by 2. This is the modular operator, which is very useful in computer science. We could also do exponentiation, which is 5 to the power 2 in this case. So we can get the result of that. These are very simple operations that we can do with numbers. There are expressions that result in values that are not numbers. So what else can we do? We can combine multiple operations. Let's say 5 to the power 2, and then divide the result by 4. So we could do that. We could use parentheses to give priorities, although in this case, we may not need the parentheses because exponentiation operator has the precedence over the division operator. So the exponentiation happens right before the division is done. So we could combine any number of those expressions together, and the precedence rules that are typically used in algebraic expressions in mathematics also apply here. What else can we do here? We could also use some sort of memory here. How can we use the computer's short-term memory, which is the RAM? Random access memory is the expensive, smaller capacity, short memory, which is very fast, that we use in our computers. So when we want to store something in that memory, we can use the assignment operator. Let's say we want to do this operation and then store the results somewhere. So this assignment operator is the way that we can use the memory. What happens is that the right-hand side is evaluated by the computer, the result is generated, and then that result is taken to the left-hand side. Left-hand side here is an English letter. So what does that mean? This is the name for a memory location, which is assigned to our program at this moment, that we can use later on in any other expression. For example, we can say that let's compute x times 2. What is x? X is a value that we stored in this line. So we can use that value, the name of that value, which is a location in memory, to do calculations here, x times 2. Or we could say that y is now x times 2 plus some other number. And then we can look up the value of y by just simply writing y and then hitting the enter button. So here what we are trying to do is that we are using memory in a very simple format. We just need to write an expression that yields value. That value is now taken to a memory location. The memory location is given a name. How can we pick names for our variables? The variables can be of any English character name. For example, we can say that result is x times 2 plus 10. So that is a perfectly valid name of a variable. We could also use underscores. So underscore by itself can be the name of a variable. So let's say underscore is now 100. Underscore is the name of the memory location that has the value 100 in it. We can say underscore times 9. Now this is 900. We could also mix in some numbers with the names of the variables. Let's say we can have x2, which is x times 2 plus 15. Now x2 is different than x. We could also use capital letters. Capital letter is used differently because Python is case sensitive. So x is something, capital X is something else. We cannot use a name that starts with a number. Let's say if we want to say 10x, assignment, let's say 1. Now we will get a syntax error. What does that mean? Syntax error is the type of error that we get when we violate one of the rules of writing Python programs. So we are not following the correct grammar that is defined by the Python language designers. If we violate one of those rules, we'll get a syntax error here. And this part is highlighted, indicating that the error occurs here. We can have a different type of error here. Let's say we want to say z plus 10. If we say that in mathematics, we could use variables that have a range of values. We don't have to always specify a value for a variable. But in Python, that's not the case. A variable is just a name for a memory location with a clear value. In this case, this program never defined something called z. So what happens if we involve z in an operation like this one? Here we get a runtime error. Runtime error is a category of errors that do not include any grammatical or syntax errors. The writing is perfectly correct here, so there is nothing wrong with the way we have written the expression. The wrong part comes from this error, name error. Name error, name z is not defined. What is going wrong here? Because we don't have anything tied to the variable z, by anything I mean any value, then Python is unable to do any calculations for us here. Or being more accurate, the computer is not able to do the calculations for us. So z plus 10 means nothing for Python or for the computer because z has no value. If we had to give z a value and then say z plus 10, then we are fine. We don't get that kind of runtime error. So runtime error happens when we write something correct in terms of the language and the grammar and the syntax, but it's impossible to evaluate, or it's impossible to execute the operation that we are asking the computer to execute. So if that happens, then we get a runtime error. We could also do something like this. We could ask the computer to divide 10 by 0. That's impossible to do. So we'll get zero division error. Division by 0 is not allowed, so we cannot do it. So the computer cannot do it. That means our program will stop executing at this point. If we were writing a longer program, the program would keep executing the commands that we are giving the computer until one of those runtime errors happen. So the runtime error would just stop the execution of the program at the point that it happens. What else can we do? So now we have expressions, we have assignments, we could have a different type of values. Up until here, we have seen just two types of values, integers and floats, which are the real numbers in Python. The reason we are calling it floating point, not a real number, is because of the technicalities of storing these values in a memory. Let's keep that aside, but for the purpose of our calculations, when we need a real number, we'll just have a floating point. So if we do a division of any two numbers, given that the division is valid, we always get a value of type float. We can test that by asking Python, by writing this function. I'll get to it in a minute. So we can write type, open parentheses, and then put down the value that we want, and then close that. So we'll get the message class float. What does that mean? That means that the result of this expression is of type float. So Python deals with any value by its type. So it would allow some operations for some types and would not allow some operations for some other types. These will be more clear when we talk about more complex expressions in future. The result of any operation, any arithmetic operation, depends on the operands. Here I have two integers. The multiplication of these two integers is an integer. If I had a multiplication like this, so one of the operands in this case is a float, I'll always get a float as a result. You just have to have one operand that is float, and then you get the result as float. 1 is different than 1.0 in this case. This is only true for all arithmetic operations except division. Division is always a float as a result. If we say 5 modulo 2.0, then the type would be float. We can now start talking about a new type, which is called strings. What is a string? A string is a type that we call it a sequence type. That means that the values of these types are created with a sequence of things. In this case, a sequence of characters. What is a character? Pretty much whatever you see on keyboard is a character. These include English letters, those symbols, the numbers, and so on. So we can say this is a value of type string. How does the compiler know that we are using something of type string? This is done by telling the compiler that this is a string. If we look at these quotation marks, these are the ways that we use to tell the compiler that this is a string. This is a value of type string, not the name of a variable, for example. We could have something like this. Now, this hello is different than this hello. This hello is a variable name. It doesn't have those quotations, but this hello has those quotations. So this is a value of type string. We can say that type of hello is str. str means a string in terms of Python. So what is now involved with the strings? We could do a few operations with the strings. If we store the value of a string in a variable, we can extract individual characters from the string. Say we want the first character of this string called s. S is the name of the variable, and this is the value of the variable. So if we want to have the first character of this string to be used somewhere else, we can write down the name of the variable, open square brackets, put down the number 0, and then close the square bracket. What does this tell us? This tells us that we are extracting the first character, which is indexed by 0. This is the convention used by Python, from this string, which is a string with this value. Now, if we want the last character of this string, we can use -1. This is clearly the last character of this string. If we want the second character, we can give it index 1. So we can see a pattern here. The indexes that we are using are used with any sequence type, including strings. So any character is given a number, which is the index of that character. They start with 0 and just increase to the right. And then they would end with the number of characters that we have -1. So that would be the last character in this string. But just a few seconds ago, I said that we can get the last character using -1. What is -1? Where does that come from? We have another option with the strings that we can use, which is using -1 and then going down to the first character. So -1, -2, -3, and so on. Let's say -2. This is the character next to the last character in the string. So as we can see, these operations are yielding values which are strings of length 1, and that's why we call these indexing operations expressions. So these are expressions of type indexing that would yield strings of character of length 1. Now, what else can we do with the strings? We can get a substring from a string. Sometimes we want some of the characters in the string, not all of them, not just one, maybe more than one. So we can do that by indicating a range of values, or a range of indexes to be precise. So we can have from index 0 to index 3, excluding index 3. That gives us HEL. Okay? And then we can have, let's say, from -3 to -1. That is just LL. We could just remove the index 0 from the expression, and it defaults to 0. If we want to start somewhere else and then go up to the last character, including the last character, we can just remove the last character's index from the expression, and we can get that. This operation is called slicing. It's different than indexing, by the fact that it can give us more than one character or less than one character. Let's say from index 7 to index 10. This string clearly doesn't have index 7 and 10 because it's just 0, 1, 2, 3, 4. So what would this expression give us? It would just give us an empty string. This is how slicing works. But if we were to index on this location of the string which does not exist, we'll just get a runtime error, which is called index error. So this index is out of range. It doesn't work like that. Okay, so this type is very useful for analyzing text, for displaying text. As you can see, this program itself is using strings heavily everywhere. These are all strings which are being used by the Python shell. Next topic is using something called built-in functions. We just saw an example of built-in functions, which was type. So type of S is str. How do we write functions? Functions are subprograms, smaller programs that we can use in our program to help us do things. A function has a name and has a set of parameters. So when we want to use a function, we have to call the function as we did here and give the function the argument that it would expect. Okay? To understand each function, we have to just look up the documentation and see the function's name and the correct way of using the function and the return value of the function. The return value of the function is the value that we expect from calling the function. It just works like an expression. Like these expressions are yielding values to us, the functions also yield values to us. That means we can store the value in a variable, which is a location in memory, and we can just look it up and see the value of that location in memory. So what are the famous functions that we can use? There are some math functions. So you can use absolute value of a number. It would give you the number. If it was negative, it will be converted to positive. We could use the power function, which is very similar to the exponentiation operator. We have that option as well. We could also use something called the length function. This one gets values of type sequence. So for example, we have a string S. Now we want to get the length of that string, which is the number of characters that exist in the string. In this case is 5. What else can we get? So any type that we study in Python has a built-in function with its name. So say we want to take the integer part of this number, int, and give a float value to int, we'll get the integer part. How about converting a string with a number to an integer? We can have strings that contain numbers. These are not dealt with as numbers in Python. So if we want to use them as numbers, we have to convert them to some numeric types. In this case, this is an integer. We can use the integer function. So we can easily say this one plus 3, for example. But we cannot say this plus 3. This is a type error, a kind of runtime error that is somehow asking the computer doing something impossible. But if the number was a real number inside the string, we have to use the float function. So this one needs a float function to be converted to float. Okay? We can also have the reverse. So if we want to get a string with the number 5 in it, we can use this type. So this one is converting something of type integer to type string.